It'll be on the 6th and 7th. It'll be what? I'm not sure. When we started the That's what we did last time. We started at 6 with you for 4 o'clock.
Alright, that's just my birthday.
Thursday has
How y'all doing? I'm almost completely well.
That's good.
Sound worse than I feel. So
Yeah. I think it's good effects of being in a basement for temporary.
yeah, it's drafting down here. Actually, it feels pretty comfortable.
That's true.
It was warm in here when we first got here, but I opened that door. Okay. So I'm going to go over these two topics. I think we'll be kind of short today, and then we'll be reviewing Wednesday and Friday. But let me talk about solution dilution. Solution dilution. Ready? Those of you who took chemistry before, you remember dilutions? M1V1 equals M2V2. If you're new to this, pay attention because it's not too difficult as long as you can identify these with the word problem. It's just plug and chug. It's a simple formula. The one refers to the initial solution, the twos refer to the final solution. And dilution means you have a solution, let's say it's in a beaker. That's my depiction of a beaker. And let's see, we've got this much liquid in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's the concentration. If I add a bunch of water to this, or solvent, whatever the solvent is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. point is, this is concentrated. If you just add pure water, you don't put more of your solute in there, and then the solute is spread out. So this is dilute, it's diluted. So the volume changes between here and here because you're adding just pure water. If water is the solvent, sometimes it's not, sometimes it's alcohol or something. But whatever your solvent is, you add pure of that, and you just basically make the solute particles further apart, and you make it less concentrated. Typically, the initial solution is like a stock solution that someone mixes up, and it's kind of concentrated. And then whatever lab you're doing, if you're working in a lab, you need a certain concentration, and you need a certain amount of milliliters to do what you want to do with it. So you go get your stock solution, you dilute it appropriately, and then you create the solution you want. That's typically a lot of labs, analytical labs. So the way this works is volume increase. Notice V1 and V2, V1 will always be less than V2, the volume, because you're adding pure water and you're increasing your volume. You can't go backwards. You actually could boil it to make it more concentrated, as long as just the solvent escaped. But you can think of it like this: there's no way to make this less concentrated. The only way to do it is, or there's no way to make it more concentrated by adding water. So that's true, and then this is also true. Maybe this isn't as obvious. So whatever higher molarity I have here, moles per liter, we're going to make it smaller here, which is why stock solutions are typically fairly concentrated. Some problems will call this the stock solution, but stock just means it's stocked in the lab and it's there for us to use. So it's all about identifying these four variables. As in any algebra problem, if you get 3 out of 4 variables, you just solve for the fourth, which is essentially what we do with these types of problems. So I'll do some examples here. These are the exercises at the end of the book. Not at the end of the book, at the end of the chapter. Chapter 8. I'm behind on creating questions, so I'm suggesting you go ahead and look at the questions in the back of the chapter to practice these. Let's do this. All right. Read this. This is example 8.3. Read this. To what volume should you dilute? When it says to what volume should you dilute, recognize that's what we're solving for. To what volume should you dilute? That's the diluted volume. 0.200 liters of a 15.0 molar solution. So this is 0.200, does it say liters? Liters, yes. A 15 molar solution. So if you can identify those, there's your 3 out of 4 variables. We're solving for that. Notice again it says to what volume should you dilute? The M2 here, to obtain a 3.00 molar solution. So we're trying to make 3.00, 0.2 liters. Yeah, so liters increase and the molarity decreases. The molarity decreases from 15 to 3, and the volume is going to increase. To what volume? Yes. Okay. So that identifies the variables. You could leave these as milliliters. I won't go into why. Even though this is moles per liter, this would still work if you just left it as milliliters. If that bugs you, you can turn it into liters if you're given milliliters. But we were given liters here. But of course, to solve for V2, I just plug and chug like that. But that'll give me the volume. Even if I just ignore units, I can go 15, 0.200. So that's M1 and V1. The liters would cancel and you'd end up in capital M, that is moles per liter. D times 0.2 divided by 3. So I end up with 1 liter. 2 times 15 divided by 3. Some questions will ask you how much pure solvent had to be added to create this, just as a secondary question. But you can see that if you had 0.2 liters, that means you've got 0.8 liters of pure water that was just added to this to bring it up. I have two of these in the back of the chapter that we can look at. 36. Y'all get the odd ones. I'll put 36. Okay. 15 milliliters of a 0.125 molar solution is diluted to 2 liters. What is the new molarity? So again, the key is, I think this is 36 at the back of the chapter. Again, the key is identifying what you've been given. 150 milliliters of a 0.125 molar solution is diluted to 2. So what is M1?
0.125.
And what is V1?
It's in milliliters. Do you want us to get it to liters?
You can leave it in milliliters.
Okay, 150.0.
I know it's not obvious why, but we're not ultimately canceling the liters and moles per liters, so it just works out to parameterize. And what do we ask for?
Into.
So we're diluting to V2 is 2.00 liters. And that's our question, what is it to? And again, it's 3 out of 4 variables divided by V2 M2. That. So it's plug and chug, 0.125, 150 milliliters, 2.00. Oh, this was milliliters too, wasn't it?
One was liters now.
Yeah, the 2 was liters.
Oh, the 2 was liters? Okay.
Yeah.
Now we have to do something about it. I would turn this into liters by going 0.150. I guess it's 0.00 liters. So these do have to match. The liters, the volumes do have to match, but you could leave it in milliliters if you wanted to. Double check that. That many milliliters to 2 liters, yeah. Okay, good call. So I turn this into 0.1500. All right, now the units match. I guess I'll say meters here. It's M. And this is 2.0 liters. But notice liters will cancel, so leave us some moles per liter. So it's really just these two that need to match. Okay, plug and chug. Divided by 2. Yeah, so that'll be my new concentration. Makes sense. Or And notice, grams was not mentioned in this problem. That's why we're kind of able to ignore the calcium acetate that's here, because it doesn't really matter what the solute is unless grams are brought up. So look at 38. They did milliliters here and liters again, so I'll turn this into 0.225 liters. And what's M1? Yeah. 1250. Those two. So what is the new molarity if we dilute to 5 liters? So M1, and the liters will cancel and we'll end up in M. So that's the new concentration after you dilute it. And you could do 1.13. You write that too. And I'm leaving the label off. I've got numerical value unit. I'm just leaving the label off because it kind of doesn't matter for these. The label in this case would have been, it doesn't even mention the solute. It didn't have to mention the solute up here. All right, let's do 40. Which was volume. So 25 milliliters of 10 molar. It's 5.0. It's just 25, so it'll be 2 significant figures. 0.150. It says to what volume, so we can report it in liters or milliliters because it's not specified. Me, I would just leave it as milliliters. M1 is 10.0 molarity, 25 milliliters, and 0.150 M. The M's cancel and will be in milliliters, and I'll just leave it like that because it didn't ask for liters. And that should do it. Times 25 divided by 0.150. My calculator says 10 molar, and you want to really dilute it a lot, so yeah, I guess that makes sense. Just repeat. If it's two significant figures, I have to have the decimal here, and these will be zeros. No, I don't have to have the decimal there, but it's, that would be the answer. Because we need two significant figures. I guess that one's only tricky because of the decimal rule. Other thing I wanted to show you today is solution stoichiometry. This is similar to what we were doing with reactions before, where we needed the grams per mole, and then we used the molar relationship, and we used the grams per mole. For the other thing, this time we're going to use concentration. Let me solve this here first. Solution stoichiometry. So look at example 8.4. Volume in liters, 0.50 molar. KCl. Solution. React with liters of .75 molar .175. Yeah, 0.175 NO3. And you are given the reactions, just like the other reactions. 2 KCl, 2 HCl. PbCl2 and 2 KNO3. Okay. Notice for these, I'll remind you what the M means. You have 0.150 molar KCl solution. But realize that's 0.150 moles per liter KCl solution. And I always tell you to write it like this. Solution to 1 liter. That's 0.150 moles of KCl to 1 liter of KCl solution. So that's what you've got here. This. And you've got 1.175 mole of PbNO2. Solution. But that means
question, here's the reaction we're given. 3, 2 of those, 2K, 2CL. So these two terms will show up. 0.150 moles of KCl to 1 liter of KCl solution. That's literally what this is telling me. I guess I should include the KCl. And then this is telling me this. And the only other ingredient is the molar relationship between KCl and PbNO3,2. So I'll write it here. Two moles of KCl to 1 mole all right. The only thing that's not over here is this. It's telling us we have this many liters of this concentration solution. So I'm going to start with this. So it's those 4 things that go into this calculation. I'm going to start with that 0.150 liters of PbNO3,2 solution. This is the molarity of that solution. This is how much of the solution you have. You start with that, you've got liters of PbNO3,2 over here. That should be solution. When it's a volume, we add the solution to it. Liters of PbNO3,2 solution. Liters of PbNO3,2 solution. So that goes on the bottom. And then what goes on top is 0.175 moles PbNO3,2. So we've used this and we've used this. Of the 2 things that are left, which one has moles of PbNO3,2? This is the only place you're going to see moles of PbNO2 between these 2. So that goes next on the bottom. 1 mole. And on top is 2 moles of KCl. Moles of KCl now needs to be on the bottom. This is what we have left, so that needs to be on the bottom. 0.15. And 1 liter of KCl solution. There we end in liters of KCl solution. Some number of liters of KCl solution. What volume in liters of 0.150 molar KCl solution? Liters of KCl solution is what we're looking for. And that'll solve it. Times 0.175 times 2 and divided by 0.150 end up with 9. That's exact. This one is exact. This is exact. This 2 is exact. And that 1 is exact. So we've got 3 significant figures, 3 and 3. calculator says, after I calculate this out, my calculator says 0.35. But I'm going to add a 0 here because it's supposed to be 3 significant figures. So that should be the answer. These are similar to the reaction problems I gave you before. The main difference is we were using grams per mole here and here. Now we're using moles per liter. And we usually had grams here, but now we've got liters there. That's the main difference. Maybe I should look and make sure they got the same answer out here. 0.35 milliliters. So there's only 2 examples at the end of the chapter. They would just be standard problems, 41 and 42. There are a few more, but they're variations on that. And we're creeping up on the test, and I think I want to just kind of keep it there. So I suppose I'll do both of these. Ellie, can you come up with more examples of these? Because there's only 2 here. So anybody comes to do these types of problems, could you come up with more of them? I hope to get to put in more of these, but I'm still dealing with family issues, so things are a little thin. So I'll just do 41 and 42 here. 41. One is the odd one that they give you the answer to, but I'll go ahead and go through it. What volume? Change to where it is. Turn that into liters in this case. That's the question, and the reaction is there's the reaction. Okay, the ingredients we're going to need for this. For one thing, well, I'll just start up here. That, go ahead and write as 0.150 moles of Na3 to 1 liter of Na3PO4 solution. So there's one of the things we'll use. We're gonna use this, but we're gonna want it in liters. Liters of CuCl2 solution. Another thing we'll use. And then we've got 0.121 molar CuCl2 here. And there's one more thing we're going to need. The molar relationship between Na3PO4 and CuCl2. Two moles. There's all the pieces. Now, you can really do this in any order, but I like to do this one first. This is the way I've been doing these. Liters CuCl2 solution. Liters of copper chloride solution. We used this. The only place you see liters of copper chloride solution is here, so this is next. 1 liter. To 0.0121 moles. 0.121. Now we got moles of CuCl2. Use this. The only place you see here is moles of CuCl2 is here. So it's 3 of this to 2 of the other. This, now we're down to that. We've got moles of Na3PO4 on the bottom. So that's this, 0.150 moles. Moles. Na3PO4. That's to 1 liter of Na3PO4 solution. And we end on liters Na3PO4 solution. And that's what we were asked for. What volume of this molar Na3PO4 solution that'll solve it? What's the same about these from our previous reactions is this, the molar relationship between the two things we're talking about. What's different is these were grams per mole before, and this was grams. Now we're talking about a quantity of liters, and we've got moles per liter for our two things we're comparing.
Here, I have a question.
Yeah.
So in this problem and the one before, we're staying on the dealing with the two reactants, but like when we work with the grams one, we did that and we worked from like going from reactants to also going to the product side as well, will it be the same with this?
There is one, that's the variation.
Okay.
I could add a few more of those if you wanted to look at 43 and 44, but I'm really just kind of wanting to stop here and go, okay, that's test one.
All right, gotcha.
But yeah, you could go, okay, what would be the concentration of this product? And it would be asking for a concentration of the product, or how many liters of the product or something like that. But let's just stick with these and creep up on test 1.0829 times 0.121 times 2 divided by 3 divided by 0.150. If I punch that in correctly, I will calculator says. My calculator says 0.0445817777. Exact. These are exact, and that is exact. So three significant figures, 3 and 3. So we need to keep these 3. 8 rounds to 5. So we end up with 0.0446 liters scientific notation would go 4.46 times 10 to the negative 2, 1, 2 liters. And I'll do one more, and just call it there, and we'll be reviewing after that. All right, so I'm going to do 42. Li2S solution is needed. With 225 milliliters nitrate, 2 nitrate. I would turn this 225 into 0.225 liters.
Is that what you're going to start with?
Yeah. Liters of CO. There's that. You've got, this. I would say 0.175 moles of CO. One 1-to-1, and then these are just 1-to-1. So these are just 1-to-1, so it's going to be 1 mole to 1 mole. Two lithiums, 2 NO3s, 1 cobalt, 1 sulfur. Yeah, that's what that was. There's our ingredients, and yeah, I'll start with this again. Liters, CO. Solution. I feel fine if I could just sit on my butt all day. But if I could gotta stand up and talk, suddenly I'm like, oh, I'm still sick. All right, now I'll get to this. Liters of cobalt nitrate. Liters of cobalt nitrate, so this is next. I used this already. This is next. Liters of cobalt nitrate solution. So 1 liter. That to 0.175 moles. Moles of cobalt nitrate, moles of cobalt nitrate. One mole to 1 mole of Li2S. Lithium sulfide, okay. We've used that. It's moles of lithium sulfide on the bottom, so we're going to use 0.125 moles. Li2S to 1 liter. And liters of Li2S solution. Let's say solution. Li2S solution. All right. So 0.225 times 0.175 divided by 0.125. 3 significant figures, exact, 3 significant figures, exact, 3 significant figures. So my calculator just says 0.315. Okay, I am going to just stop there for test 1. We can start reviewing Wednesday and Friday. Definitely look at these questions. The last few questions I've given you, I didn't make on detail, so pay attention to what I put up here in the last couple of videos. Practice those. I'll try to get some of those done. Maybe I'll feel good enough to do it. But for now, just look at that. Be ready with any questions you have. Going all the way back to the beginning. You can ask any of that to review.
Thank you.
Yeah.
Feel better.
I'm getting there.